Hello. So in this video of geometric progressions, we're going to look at how you can find the sum to infinity, of a convergent geometric series. And the fact that it's a convergent series is actually really important. So even before we start, it's probably worth just talking about what convergent means and how that's different to a divergent series. The main difference is that in a convergent series or sequence, the numbers are getting smaller and smaller and smaller each time. And so if you think about the sum of all those terms, there's even if it goes to infinity, it's going to have a limited quantity because the numbers are getting smaller and smaller and smaller, like 10, 5, 2.5, 1.25, 0.625, and so on. They're getting, 0.75. They're getting smaller and smaller. Whereas if the sequence is getting bigger and bigger, like 3, 6, 12, 24, 48, and so on, as you go further along, the numbers are getting bigger and bigger and bigger, and the sum will just always get larger. So you can only use this formula, you can only do what we're doing in this video, for a convergent geometric series. Now, if they ask you to find the sum to infinity, you can be pretty sure that it's convergent because you couldn't do the question otherwise. But that's just important to bear in mind. So if we look at this particular question, which is pretty typical, it says find the sum to infinity of the following series. 8, 4, 2, 1, so on, so on, so on. And the formula to use here is this one here. It's pretty small, but you just got to memorize it and you plug the values in. So we just do A divided by 1 minus R. It's as simple as that. So we look at our sequence, or our series in this case, because there's plus signs in between, so it's a series rather than a sequence. The first term is 8, so A is 8. Oops, sorry, didn't mean to write A there, it's 8. And then R, the common ratio, is just whatever is happening between them. So one thing to be careful of here is, to get from 8 to 4, you might think that you just divide by 2. However, in geometric series or sequences, the common ratio always wants to be what you have to multiply the term by. So I actually want to put times 0.5. You have to multiply 8 by 0.5 to get to 4. Then I multiply 4 by 0.5 to get to 2, multiply 2 by 0.5 to get to 1, and so on. So my next terms would be 0.5, 0.25, and so on. So R is 0.5. Then we can just plug these into this formula. So scroll down a bit. Our sum to infinity, this little kind of figure of 8 symbol that's been tilted on its side, is the infinity symbol, is equal to A, which is 8, divided by 1 minus R, which is 0.5. So I've just got 8 over 0.5, because 1 minus 0.5 is 0.5. And that gives us 16. So the answer is 16. So what we're really saying here is if we added all of these up, we would tend towards 16. Like if we carried on this series for an infinite number, like I carried on doing plus such and such, such and such and such, like all the way infinitely long, and I added together all the terms, it would get close to 16. Like it wouldn't actually reach, kind of theoretically it would reach 16, but not really. And we can see that, like if we do 8 add 4, that's 12. Add 2 is 14. Add 1 is 15. Add 0.5 is 15.5. Add 0.25 is 15.75. The next term would be 0.125. So now we're on 15.875, and so on and so on. I keep on adding more and more and more, and we just get closer and closer to 16. But we wouldn't ever go higher than 16. So this here is a convergent series because we're getting smaller and smaller and smaller numbers, and we can find the sum to infinity using this formula. Whereas if it was a divergent series, we wouldn't be able to use the sum to infinity formula. We couldn't find the sum to infinity. So that's it. I hope that makes sense. Have a go at the MCQs down below. You just want to kind of bash through a few examples. And hopefully this isn't too hard. You just really need to remember this formula here. But yeah, well done for making it through, and I'll see you in the next one. Thanks.